Welcome, everyone. Today, we are looking at Topic 2 in your SS3 Physics series, Electrostatics. This topic covers Coulomb's law and electric fields. It is frequently tested in your objective questions. You must understand the concepts and calculations well. Pay close attention. Let us begin. First, let me explain what electrostatics is. Electrostatics is the study of electric charges at rest. It deals with the forces, fields, and potentials associated with stationary charges. It is a branch of physics that has many applications. Understanding electrostatics is essential for understanding electricity and electronics. It is the foundation for many technologies we use today. Let us start with the basic concept of electric charge. Now, let me explain electric charge. Electric charge is a fundamental property of matter. It comes in two types: positive charge and negative charge. Like charges repel each other. Unlike charges attract each other. The unit of charge is the coulomb. The symbol for charge is Q or Q. The charge on an electron is negative 1.6 times 10 to the power of negative 19 coulombs. The charge on a proton is positive 1.6 times 10 to the power of negative 19 coulombs. Charge is quantized. It exists in discrete amounts. The total charge in a system is conserved. It can neither be created nor destroyed. Understanding electric charge is essential for understanding electrostatic interactions. This is the foundation of the entire topic. Now, let me explain the methods of charging. There are three main methods of charging objects. The first method is charging by friction. This occurs when two different materials are rubbed together. Electrons are transferred from one material to the other. One object becomes positively charged. The other becomes negatively charged. Examples include rubbing a glass rod with silk and rubbing a plastic rod with fur. The second method is charging by conduction. This occurs when a charged object touches a neutral object. Charge is transferred through direct contact. The neutral object becomes charged with the same type of charge. The third method is charging by induction. This occurs when a charged object is brought near a neutral object without touching. The charges in the neutral object are redistributed. One side becomes positive. The other side becomes negative. The object can then be grounded to give it a net charge. Understanding these methods is essential for understanding how objects become charged. These concepts are frequently tested in your examinations. Now let me explain Coulomb's law. Coulomb's law is the fundamental law of electrostatics. It states that the force between two-point charges is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. This is another inverse square law. The formula is F equals K times Q1 times Q2 divided by R squared. Here, F is the electrostatic force between the two charges. K is the electrostatic constant. Q1 and Q2 are the magnitudes of the two charges. R is the distance between the centers of the two charges. The value of K is 9 times 10 to the power of 9 Newton meters squared per Coulomb squared. This value is also equal to 1 divided by 4 pi epsilon naught, where epsilon naught is the permittivity of free space. Understanding Coulomb's law is essential for solving electrostatic problems. This is one of the most important formulas in physics. Now, let me explain the properties of electrostatic force. The electrostatic force has several important properties. First, it can be attractive or repulsive. Unlike charges attract, like charges repel. Second, it is a central force. It acts along the line joining the centers of the two charges. Third, it obeys the inverse square law. The force decreases with the square of the distance. Fourth, it is a conservative force. The work done by the electrostatic force is independent of the path taken. Fifth, it is a long-range force. It acts over infinite distances. Understanding these properties is essential for understanding electrostatic interactions. Each property describes a different aspect of the electrostatic force. Now let me explain electric field. An electric field is a region of space around a charged object where another charged object experiences an electrostatic force. Every charge creates an electric field around itself. The field exists everywhere in space. It is represented by field lines. The field lines point away from positive charges and towards negative charges. The electric field strength is the force per unit charge at a point in the field. The formula is E equals F divided by Q. Here, E is the electric field strength, F is the electrostatic force, Q is the charge experiencing the force. The unit of electric field strength is Newton per Coulomb. Understanding electric fields is essential for understanding how charges interact without touching. The field concept helps us visualize the influence of a charge on its surroundings. Now, let me explain electric field strength due to a point charge. The electric field strength at a point due to a point charge can be calculated using a specific formula. The formula is E equals K times Q divided by R squared. Here, E is the electric field strength. K is the electrostatic constant. Q is the charge creating the field. R is the distance from the charge to the point where the field is being measured. This formula shows that the field strength decreases with the square of the distance. It is stronger closer to the charge. It is weaker farther away. Understanding this formula is essential for calculating electric field strengths. This is a common calculation in your examinations. Now, let me explain electric potential. Electric potential is the work done in bringing a unit positive charge from infinity to a point in an electric field. It is a scalar quantity. It is measured in volts. The formula for electric potential due to a point charge is V equals K times Q divided by R. Here, V is the electric potential, is the electrostatic constant. Q is the charge creating the field. R is the distance from the charge to the point where the potential is being measured. Unlike gravitational potential, electric potential can be positive or negative depending on the sign of the charge. A positive charge creates a positive potential. A negative charge creates a negative potential. Understanding electric potential is essential for understanding the energy of charges in an electric field. This concept is frequently tested. Now, let me explain the relationship between electric field strength and electric potential. There is an important relationship between these two quantities. The electric field strength is the negative gradient of the electric potential. In other words, it is the rate of change of potential with distance. The formula is E equals negative dV over dr. This means that the field strength is the slope of the potential distance graph. A steeper slope indicates a stronger field. Understanding this relationship is essential for understanding the connection between force and energy in electric fields. This concept links the two fundamental aspects of electrostatics. Now let me explain electric potential energy. Electric potential energy is the energy possessed by a charge due to its position in an electric field. It is the energy stored in the charge because of its location. The formula for electric potential energy is U equals Q times V. Here, U is the electric potential energy, Q is the charge, V is the electric potential. For two-point charges, the formula is U equals K times Q1 times Q2 divided by R. The potential energy can be positive or negative. Like charges have positive potential energy, unlike charges have negative potential energy. Understanding electric potential energy is essential for understanding energy conservation in electric systems. This concept is frequently tested in your examinations. Now, let me explain the difference between electric field and electric potential. Many students confuse these two concepts. Let me clarify the difference. Electric field is a vector quantity. It has both magnitude and direction. It is the force per unit charge. Electric potential is a scalar quantity. It has only magnitude. It is the work done per unit charge. The electric field is the negative gradient of the potential. You can think of the field as the slope of a hill and the potential as the height. The steeper the hill, the stronger the field. Understanding this difference is essential for solving problems correctly. This distinction is frequently tested. Now, let me explain conductors and insulators. Conductors are materials that allow electric charges to flow freely. They have many free electrons. Examples include metals like copper, aluminum, and gold. Insulators are materials that do not allow electric charges to flow freely. They have very few free electrons. Examples include rubber, plastic, and glass. In electrostatics, charges reside on the surface of conductors. The electric field inside a conductor is zero in electrostatic equilibrium. The electric potential is constant throughout a conductor. Understanding conductors and insulators is essential for understanding how charges behave. This concept is fundamental to electricity. Now let me explain the applications of electrostatics. Electrostatics has many applications. In industry, electrostatic precipitators are used to remove dust and smoke from exhaust gases. In printing, electrostatic printing is used in photocopiers and laser printers. In agriculture, electrostatic sprayers are used to apply pesticides more efficiently. In medicine, electrostatics is used in electrocardiography and defibrillators. In everyday life, static electricity causes clothes to stick together and hair to stand up. Understanding the applications of electrostatics is essential for understanding how this principle is used in technology. Now let me explain the importance of electrostatics. Electrostatics is important for several reasons. First, it explains the fundamental interactions between charges. It is the basis for understanding electricity. Second, it is used in many technological applications, from printers to air purifiers. Third, it is essential for understanding electric circuits and electronics. Fourth, it helps us understand natural phenomena like lightning and static electricity. Fifth, it is a foundational topic for more advanced studies in physics and engineering. Understanding electrostatics is essential for physics and technology. It is a fundamental part of our world. Now, let me give you sample exam questions to prepare you for your test. State Coulomb's law. Coulomb's law states that the force between 2-point charges is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. State the formula for Coulomb's law. F equals K times Q1 times Q2 divided by R squared. Define electric field. An electric field is a region of space around a charged object where another charged object experiences an electrostatic force. Define electric potential. Electric potential is the work done in bringing a unit positive charge from infinity to a point in an electric field. State the formula for electric field strength due to a point charge. E equals K times Q divided by R squared. State the formula for electric potential due to a point charge. V equals K times Q divided by R. What is the difference between electric field and electric potential? Electric field is a vector quantity that is the force per unit charge. Electric potential is a scalar quantity that is the work done per unit charge. Explain the difference between conductors and insulators. Conductors allow charges to flow freely. Insulators do not allow charges to flow freely. Let me summarize everything we have covered today. Electrostatics is the study of electric charges at rest. Charge comes in two types, positive and negative. Like charges repel, unlike charges attract. Coulomb's law describes the force between 2-point charges. The electrostatic force is inversely proportional to the square of the distance. Electric field is the region around a charge where a force is experienced. Electric potential is the work done per unit charge. The field is the negative gradient of the potential. Conductors allow charges to flow, while insulators do not. Electrostatics has many applications in industry, printing, agriculture, and medicine. Understanding electrostatics is essential for physics and technology. This is topic 2 in your SS3 physics series. Study it well. It is frequently tested in your objective questions. Well done.